All right, geometry students, so today we are going to be talking about our next lesson, proving lines are parallel. So now that we know the different angle relationships that are formed when two parallel lines are cut by a transversal, we're going to use the converses or the reversals of statements about angle relationships to prove lines are parallel. We're basically working backwards today. So in this lesson, we're going to talk about what even is a converse. We're going to talk about the converses of these angle postulates we learned last time. We're going to practice proving lines are parallel. We're going to talk about the transitive property of parallel lines. And we are going to prove lines are parallel with algebra. Your best course of action today would be to follow along with our guided notes, as well as complete the additional practice problems when prompted. So let's begin. So first, let's talk about what's a converse. So a converse is essentially the reversal of the if and the then portions of a conditional statement. We know that in science class we use a lot of hypothesis conclusion statements, if, then, because. So here's an example. If it is raining, then the grass is wet. So our hypothesis would be it's raining. Our conclusion would be the grass is wet. Now, if we reverse the order of these statements, this would be the converse. So instead of if it is raining, then the grass is wet, we have if the grass is wet, then it is raining. And converses, when we reverse if-then statements, can sometimes be true and sometimes be false. So in this particular instance, if we think about it, if grass is wet, it doesn't necessarily need to be raining. There could be a sprinkler running outside, or maybe it's dew from the morning. So not necessarily true. But in our case today, all of our converses are true. So here's a statement. Here's a postulate we learned about last time. Then it says, if two lines cut by a transversal are parallel, then corresponding angles are congruent. Now, if I take the converse of that statement, I'm going to have to rework it a little bit just so it makes grammatical sense, but it would look something like this. If corresponding angles are congruent when two lines are cut by a transversal, that's the previous then statement. If corresponding angles are congruent when two lines are cut by a transversal, then the lines are parallel. So we're going to use statements like this to prove lines are parallel today. So let's take a look at what those are. So we have 5 converses that we are going to use to prove lines are parallel today. The first is the one we just talked about. That's the corresponding angles converse. And that says, if two lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. And the main takeaway you need from this would be, if a pair of corresponding angles are congruent, then lines are parallel. So we have lots of examples of corresponding angle pairs to choose from. I'm just going to take the first one I see. That's angles 1 and 5. They are corresponding angles. So my example would be, if angle 1 is congruent to angle 5, then our lines are parallel. Then L is parallel to line M. Let's look at the next one, the alternate interior angles converse. If a pair of alternate interior angles are congruent, if that is true, then the lines are parallel. So let's find an example of alternate interior angles in this diagram. I'm seeing, if I look inside these parallel lines, or inside lines L and M, I can see angles 4 and 6 or 3 and 5. So let's just use angles 4 and 6 as our example. If angle 4 is congruent to angle 6, then line L is parallel to line M. Now we have the alternate exterior angles converse. That says if a pair of alternate exterior angles are congruent, then the lines are parallel. So looking at my pairs of alternate exterior angles, that would be either angles 1 and 7 or angles 2 and 8. So I'll just use angles 2 and 8. If angle 2 is congruent to angle 8, if they are the same measure, then line L is parallel to line M. Now into our consecutive or same side converses. Consecutive just means same side of the transversal line. So the consecutive interior angles converse says that if a pair of consecutive interior angles are supplementary, then the lines are parallel. So if we think about our consecutive interior angles, that would be either angles 4 and 5 or 3 and 6. So let's just choose 4 and 5. So if they are supplementary, if the measure of angle 4 plus the measure of angle 5 equals 180 degrees, then line L is parallel to line M. And lastly, the consecutive exterior angles converse. That states if a pair of consecutive exterior angles are supplementary, then the lines are parallel. So if we think about consecutive exterior angles, they are on the same side of this transversal line and on opposite sides of lines L and M. So that's either angles 1 and 8 or 2 and 7. Let's just use angles 1 and 8 for the purpose of this. If the measure of angle 1 plus the measure of angle 8 equals 180 degrees, then line L is parallel to line M. So these are the 5 angle relationship converses that we are going to be using to prove lines are parallel today. We cannot prove that lines are parallel using vertical angles or linear pairs, so that's going to come in handy for us in the next couple slides. So we are asked when we practice here to determine if line L is parallel to line M based on the information given in the diagram. If yes, we're going to state the converse that proves the lines are parallel. So when we take a look at this, at number 1, I see two 63-degree angles, and I am seeing that they are alternate exterior angles. So we can say yes, these lines are parallel because of the alternate exterior angles converse. And I'm abbreviating angles as the angle symbol followed by S, angles. And that is the converse. So if you notice that a pair of alternate exterior angles are congruent, they're the same measure, you can say that the lines L and M are parallel by the alternate exterior angles converse. Now let's look at number 4. I see two 105-degree angles. I see that they are congruent, but they have a different relationship. This is a pair of vertical angles, meaning that when two lines intersect, the angles across from each other are the same measure. Now, this isn't even involving line L, so there is no way that we can prove lines are parallel with just these vertical angles. So I would say no, vertical angles can't prove lines are parallel. Just like that. If you would like additional practice with this concept of determining whether lines are parallel based on these angle relationships, you can take a look at problems 2, 3, 5, and 6. So let's get a little bit more complicated here. Here I have two sets of lines that intersect each other. And so in order to determine angle relationships, I may have to redraw this diagram, and I'll show you what I mean in just a second. So, given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. So, I am first looking at letter A. I want to prove, or I'm given that angle 2 is congruent to angle 4. And so I don't really need any of the angles below. I don't need angles 9 through 16 in my way right now. So just a helpful tip, redrawing your diagram, and it doesn't have to be perfect. You just need to know the orientation of the angles you're focusing on. So I have, this is lines C and D. And here's line A. And I know I'm trying to look at the relationship between angles 2 and 4. So I'm just redrawing what I need. So when I look at these angles, I notice that they're in corresponding places on lines C and D. So in this case, I'm going to say, since they are corresponding, and since angle 2 is congruent to angle 4, I'm going to say line C is parallel to line D. And my reason would be the corresponding angles converse. They are corresponding angles, and they are congruent to each other. Okay, let's take a look at angles 5 and 10. And just for some clarity here, I'm going to redraw the diagram to fit my needs. So I really only need this left portion. And this is just to provide visual clarity for me. If you don't need to redraw diagrams, you don't have to. But let's say, so I've got lines A and B, and this is line C. And I am taking a look at the relationship between angles 5 and 10. Now I am seeing that they are inside lines A and B and on opposite sides of the transversal line. So angle 5 being congruent to angle 10, this would make them alternate interior angles. That would make line A parallel to line B. So since they are congruent, that makes line A parallel to line B by the alternate, abbreviating here, interior angles converse. Okay, I'm going to do a few more. So now my next one is the measure of angle 1 plus the measure of angle 13 equals 180 degrees. So I'm looking at angle 1, and angle 13. I see, if I'm just focusing on the left side of the diagram, I see that they are consecutive exterior angles. And since they're supplementary, that means that lines A and B are parallel. Lines A and B are parallel, and that's because of the consecutive exterior angles converse. Okay, angle 1 is congruent to angle 14. Angle 1 and angle 14. Now these particular angles, I see that they're on opposite sides of lines A of the transversal line C, and they're outside of lines A and B. And if they're congruent, that means that lines A and B are parallel yet again. They're alternate exterior angles. So this would be proving lines A and B are parallel by the alternate exterior angles postulate. Okay, if the measure of angle 14, let me do some erasing here. If the measure of angle 14 plus the measure of angle 15 equals 180, so we're saying we're looking at angles 14 and 15 here. If their measures equal 180, that means they're supplementary to each other. And they are positioned as consecutive interior angles inside lines C and D. So I'm going to say that lines C and D are parallel. Line C is parallel to D by the consecutive interior angles postulate. And we're given that angle 11 is congruent to angle 16. Angles 11 and 16. I can see right off the bat that these are vertical angles, and we know that we can't prove any lines are parallel just given a pair of vertical angles. So I'm going to say there's no parallel lines I can prove here. And of course, no converse. 11 and 16 being congruent means nothing about parallel lines. If you'd like some additional practice, you can finish filling in the table for problem 7, and there's also problem 8 that you can practice with. Now let's talk about another property of parallel lines. This is called the transitive property of parallel lines. And it states that if two lines are parallel to the same line, then they are parallel to each other. So for instance, if line P is parallel to line Q and line Q is parallel to line R, meaning line Q is parallel to both lines P and R, that means that line P is also going to be parallel to line R. If P and R are parallel to line Q, then they are parallel to each other. So let's take a look at this example. If A is parallel to C, if line A, I'm going to mark it here with my arrows. If line A is parallel to line C, I need to find out which other lines are parallel and why. So I need to look at some angle relationships here. So if I am taking a look, I am seeing a pair of consecutive exterior angles. Notice the 84-degree angle and the 96-degree angle. If I redraw this, so I'm saying I see on line B and line C, I'm seeing an 84-degree angle and I'm seeing a 96-degree angle. And I'm noticing these are, if you add up 84 and 96, the sum would be 180. That means these are consecutive exterior angles and they are supplementary to each other, which means that lines B and C are parallel. Line B is parallel to line C because of the consecutive exterior angles converse. And now we know quite a lot. If we know that line A is parallel to line C, and we know line B is parallel to line C, then we also know by the transitive property of parallel lines that line A is parallel to line B. Again, that is the transitive property of parallel lines. Okay. So now let's move into some algebra practice. We want to be able to model equations that allow us to prove lines are parallel. So our directions state to find x so that line A is parallel to line B, and to state the converse used. I actually want to identify the converse first. That's going to allow us to set up our equations easier. So in problem number 1, I see this angle here is 10x minus 23 degrees. And I see its alternate interior angle pair is 37 degrees. Now, we can use the alternate interior angles converse to set these values equal to each other. If these values are equal to each other, that means that line A is parallel to line B. So again, the converse was the alternate interior angles converse. And so we just need to find the value of x that makes these lines parallel. So I'm going to set up the equation 10x minus 23 is equal to 137 because I want these values to be the same. I want the angles to have the same measure. So let's solve this equation. We're going to start by adding 23 to both sides. This is eliminated. 10x is equal to 160. We'll divide both sides of the equation by 10. This is reduced to 1, and x is equal to 16. So these lines A and B, are only parallel if x equals 16. Any other value of x would make these lines not parallel. Let's try one more. And I'm seeing there's a 74-degree angle and an angle that is 9x plus 11 degrees. Their position is makes them corresponding angles. They're in the same position on line A and line B. So I want to use the corresponding angles converse to prove these lines are parallel. The corresponding angles converse states that if two corresponding angles are congruent, then the lines are parallel. So congruence just means same measure. I want these angles to equal each other. So my equation would look something like this. 74 equals 9x plus 11. So I'm going to subtract 11 from both sides of the equation. This is eliminated, and we get 63 is equal to 9x. And when we divide both sides of the equation by 9, 9 is reduced. 63 divided by 9 would be 7, so x equals 7. Any other value of x would make line A not parallel to line B. If you'd like more practice with proving lines are parallel with algebra, I recommend trying some of the examples from 3 through 10. All right, so that was our lesson about proving lines parallel. Make sure that you try out some additional practice problems. You don't have to try all of them, just enough for you to understand the concept fully. You can check your answers with my filled-in notes, and please make sure you are checking in the content library in the Topic 2 Notes folder. Please make sure you're asking for support in Math Help Desk if you need it, and I hope you have a lovely day.